So hope you had a lunch. Now after the lunch session, and you know how difficult it is to attract the audience. And as a teacher also, so we have felt the same thing with respect to the students. So let us see. This is the second session. So myself, Dr. K. Shanmukha Sundar, heading electrical engineering department of this institution, also coordinator of this event. So I'll be taking the session on cyber security for digitalized green technologies. So as I am electrical person, so there are different sectors are there. Digitalized green technologies. So this is applied to different sectors. So I will be taking it is digitalized green technologies applied to the power sector. So before taking, because participants are from different streams, so I will be taking out the basics, then I will be moving on to the technical things. So this is the thing we will be doing it. So let us see first what is sustainability. So entire sustainability definition lies in this figure. So you can see this figure, what is actually sustainability. So you can see if it is clear for you, so there is a wind plant is available there, solar is available there, then eco-friendly cycling and oxygen increase we have to do, and eco-friendly technologies we have to make it. So it is very complex term. It is a very complex term, sustainability. So it centers around the concept of energy saving. First thing is energy saving. The second thing is environmental pollution. And in general, we can say that one, we have to safeguard the planet. That is the picture representation. Finally, you can see that one, we have to safeguard the planet with respect to energy saving, then environmental pollution, etc. and all those things. So that is the basic definition of our sustainability. Then coming back to green technologies. Whatever the technologies we are having it that are not environmentally friendly. So the technologies that is considered environmental friendly are known as green technologies. Now what are these green technologies? So let us see, we are to use So the main aim or the design of green technology is to reduce the environmental impact of our technical resources. So from this one only the green technology has arisen. Now what is that one? So we'll be using science and technology to create the environmental friendly So GT means it is green technology. So it promotes the creation of environmentally friendly technology products as well as the recycling of the electronic trash. Means we have to use science and technology to create the technological products and services which are environmental friendly. So that is the thing. So also this green technology contribute to socio-economic development of the country, keeping it in mind the natural resources. And these technologies, some of the green technologies include your production of clean energy using renewable energy sources, recycling of robots, then electric vehicles, financial technology, AI, information and communication technology, etc. So all these corresponds to your green technologies. Then coming back to, after knowing what is sustainability, is safeguarding the planet. Green technologies means we should have a technological products and services which are environmentally friendly. So knowing this sustainability and green technology, how this will be applied to a one sector we are considering it, that is power sector we are considering it here. Again, I will be coming back to your sustainability and green technologies after giving the brief description about the power sector in India. Now, you see the power system is very complex and it is dynamic analysis is very difficult. Power system means it is a power sector. Why? The first thing is lack of situational awareness. What is lack of situational awareness? So knowing the present status, predicting the future state of the system. So that is known as your situational awareness, that is SA. That is lacking. That's why we call it as a power system is very complex. There are few more reasons are there. So this situational awareness is monitored by PMUs, synchrophasers and SCADA. That means to measure everything we need some instruments. So in power sector, we are having PMU, phasor measurement units, synchrophasers and SCADA. These are the extra, this one we will be having it to predict the situational awareness. Then the data received from the PMUs and synchrophasers will be at higher resolution as compared with the SCADA. But still, the information or data that is received from PMUs or from synchrophasers, still we consider it as a low resolution as compared with the situational awareness, or when it is compared with the real time. Still we feel that one it will have a low resolution. So that is the thing we have been seeing it. Now what is that one? The second problem is environmental concerns. The second point of calling power system is a complex is environmental concerns. That is, everyone are saying you move from transition to green energy or green power. So that how to achieve? So in the power sector, we will be using it, wind and solar power plants will be using it. So this is why there is a problem with wind and solar, because of intermittency. So because of this intermittency, lot of harmonics are generated and are injected into the power system. So because of this intermittency only, we feel that one, so the environmental concerns are very difficult in the power sector. Then also we are having stability and power quality issues will be there. Stability and power quality issues also will come into picture. Then the third one is frequent cascading outages. So frequent cascading outages are happening. So this leads to a blackout. So are you aware of any incident that has happened in India? Blackout. So in 2012, so it has happened, there is a blackout happened because of cascading effect. So you know that when we are having 5 grids, that is 5 reasons we are having it in India. So because of this one, so in the conventional grid blackout occurs, it leads to cascading effect. So because of this one, so one component fails, next it is, because of cascading effect, the other equipments are going to fail. Now this is the biggest blackout it has happened in the history in 2012. So first it has happened in northern grid, then it started to eastern grid, then northeastern grid. 3 grids have failed. You can see here. You can see here. These are the 5 regional grids are there. Southern grid, western, northern, eastern and northeastern grids. So out of these 5 regional grids, we are having it. So the first problem has happened in the northern grid. Then it has led to the tripping of the eastern, then northeastern grid. So entire northern India, eastern India has faced the blackout in the year 2012. You can see there. So that is a complete picture where that is happening between northern state, northeastern states and northern India. Complete blackout has happened in 2012. Almost in these regions, they did not have a power for almost 3 days. Now you see here, two separate massive blackouts happened. That means on 30th and 31st of July, and it has resulted in 700 million people from 22 states are without electricity for almost 2 days. First northern region it has happened, it is for 3 days. Then because of cascading effect, so almost they did not have a power for 2 days around the 22 states. So almost it is estimated that 32 gigawatt of electricity was taken off from the line on 30th and 31st July. So these two blackouts caused a huge financial loss to the Indian economy. So the situation of blackout could have averted. Why it has happened? Because the Indian power sector that time didn't have a powerful communication. So they were using VLCC for communication. So this VLCC was not sufficient to give the signals frequently. So that was the problem it has caused. So it did not have a powerful communication system. So later they have used in Karnataka from 1998 onwards, they have included for a communication VSAT technology. So from 1998 onwards, there was no blackout in Karnataka. Before that one, there were small blackouts were there, but when they implemented VSAT communication technology, we didn't have any blackouts. Then the existing power is neither it is designed for the latest technology, nor it is comply with the rapidly changing climate. This is the one more problem we are having it. So another problem is there is environmental changes are happening. Energy crisis is there. Why energy crisis is there? Because increase in demand. So because of that one, energy crisis is increasing day by day. So this has given, or this has forced the researchers and academicians to think about the sustainable technologies in power sector. So we have to check what is the sustainable technology that we can bring in one sector, that is power sector. So that one sustainable technology is your smart grid. One such sustainable technology in the power sector they brought in, that is known as your smart grid. So what is a smart grid? Before going to that one, again, after giving the brief introduction about power sector, so let us see again sustainability and green technology. So as per International Energy Agency, the usage of electricity around the world will grow by 20% in the coming decade. So fast it is increasing. So therefore, one of the key topics in the climate summits, you have seen so many climate summits are happening. Any climate summit, one of the key points that will be discussed in all the climate summits will be transition to green energy. You have to move from the power sector point is there, then you move as quickly as possible, transition to green energy. You have to shift it. So this is a key point in all the climate summits, it will be discussed. So how to make our power sector to make transition from the present status to green energy. So the transition to green energy, it is not easy task. It needs intelligent grid. The grid must be intelligent enough, and it is capable of managing complexity associated with renewables. Green energy means you will be having renewables, solar and wind. That is the first thing which will come into our mind. So therefore, intermittency will be there in the renewables, as already we have seen. Because of that one, lot of harmonics are injected into the system. So it has to manage the complexities associated with the renewables. The grid must be intelligent and it should manage the complexities associated with the renewables. Now you see, there is no green without digital. Yes, we have to move from the conventional to green energy, but how to move this one? So first thing is conventional grid has to be digitalized. Then only we can say that we can move to the green energy. So there is no green without digital. So therefore, we have to digitize the existing grid. So conventional power sector combined with ICT, that is information communication technology, is your digitalized power sector. So whatever the conventional power system is there, just you add information and communication technology. So then it will become digital power sector, which is intelligent. So that intelligent grid, we will call it as a smart grid. Now you know the difference between conventional grid and smart grid. Conventional grid means the general grid, what we are having it. If you add information and communication technology to the existing grid, then we will call it as a smart grid. And obviously, why it is called smart grid? So it will reduce the carbon dioxide emission up to 25%. It is reducing the carbon dioxide by 25%. Can we call this smart grid as a green grid now? Because it is reducing the carbon dioxide, obviously. That is the aim. Isn't it? Sustainability means what? It must be environmentally friendly. The technologies must be environmentally friendly. So here smart grid reduces carbon dioxide emissions by 25%. So we can call this smart grid as greener grid. We'll call smart grid is a greener grid. I don't know, color was greener, but it is appeared here it is blue. I made it as a green only there. Okay, now let us see how we can authenticate the smart grid is a greener grid. So let us see. First, the smart grid we are having, we'll see. First, it will enhance the demand response. The smart grid will enhance the demand response, helpful for load control. Then, the second one, we'll be having transform customer energy usage. Then, the third one will be, it will improve operational efficiency. Also, smart grid will enhance the customer service. These are the 4 advantages we will be having it from the smart grid. Now I want to authenticate that smart grid is your greener grid. For that one I am showing it this one. First let us take this demand response or load control. So what happens, because of demand response and the load control is done, so there will be a reduction in the peak demand. So whenever peak demand is reduced, it is easy for us to integrate the renewable energy sources. So we can easily deploy the renewable energy sources. That means what? Peak demand reduced. What you are saving here, once again, usage is reduced, that is peak demand is reduced, and you are integrating the renewable energy easily. So what is saved? You have saved energy here. So this leads to energy savings. Then transformer customer energy use. So how the smart grid will transform the customer energy use? The customers will get a feedback, direct feedback and indirect feedback from their appliances. Direct feedback from their appliances, that is your mobile app. Indirect means through your billing system. They will be getting the billing system. So they will now, in future it will be dynamic pricing. During peak loads, the cost per unit will be more. So obviously what you will do, if cost is more, what you will do during the peak demand? Suppose 5 rupees per unit during peak load. What you are going to do? You will switch off unnecessary that is commodities, whatever you use. So what you are doing, ultimately energy save, isn't it? So this is how it is going to help. So you will get feedback, direct feedback from the display devices, that is mobile apps, and indirect feedback you will be getting from the billing system. So then what you will do, that is a general tendency. No, suppose if you are getting 3,000 bill, next month what you will do? You try to reduce the bill, isn't it? So that is the advantage you will be getting it. Obviously here also you are saving energy. Then improve operational efficiency. Smart grid will improve operational efficiency. What it means? So it means losses are reduced here. So line losses are reduced. So transportation reduced through the AMR. AMR means automatic meter reading. Smart grid, whenever it is implemented, now advanced metering infrastructure is going to come, in which smart meters are going to come. So all your conventional energy meters, what you are having, it will be replaced with the smart meters. So line loss reduction will be there because there is an increase in operational efficiency. Transportation is reduced through automatic meter reading. So obviously this will give you once again energy saving. Enhance customer service. So once again it will enhance the customer service. How it will enhance the customer service? Availability of green power. From where you are getting green power? From renewable energy sources. Again, dynamic pricing will come into picture here. Because of dynamic pricing, so the consumers will become, that means will become that during the peak load, so they want to shut down their appliances which are consuming more power. So again, this will lead to your energy savings. You have saved the energy. Means what is the outcome? You have saved the energy, okay, your bill has reduced. What is the entire impact on the power sector? Will the generation will be increased or reduced? Generation. Energy you have saved. Instead of consuming 100 units, you are consuming 80 units. You assume it. 200, a local grid is generating 200 units. Example, I am saying it. So what happens? Is it 200 units generation is required, or generation will be reduced or increased? It should be reduced. So generation reduced means, what are the power plants we are having it? Thermal is there. So you can reduce the power generation. So from the thermal and the nuclear, so that your, obviously this energy savings leads to a reduce of carbon emission. This leads to a reduce the carbon emission. This is the advantages. I can show it, say that to authenticate my smart grid is reducing the carbon emission, so that I can call it as a greener grid. Not only that, so this smart grid will have the lot of renewable energy sources integration. So renewable energy sources, again it leads to a reduction in carbon emission. Our electrical vehicles, PHEVs, plug-in hybrid electric vehicles also connected to the smart grid structure. So this also reduce the carbon emission. So this is the complete scenario of your smart grid to authenticate that it is a greener grid. Okay, next, let us see how smart grid and industry 4.0 are combined. So let us see here, smart grid applies industry 4.0 principles for better power system operation, then for higher energy efficiency, reduced generation and operation costs. The important point is lower greenhouse gas emission, reduced power losses, improved energy quality, and effective management of generation and storage system. So this is how we are combining the industry 4.0 with the smart grid technologies. When smart grids employs or apply the industry 4.0 principles, these are the advantages we will be getting it in the power sector. So let us see, before going into the actual topic, what was the actual topic? Cyber security. So we will go into the topic, so you should understand the structure of the smart grid. So this has mainly electrical infrastructure and information infrastructure. Already I have shown it that one. Information infrastructure means ICT, information and communication technology. Electrical infrastructure means our conventional power system, generation, transmission and distribution will be there. That is our electrical infrastructure. Then the second one will be information infrastructure. So we call this smart grid as next generation grid, and will be a new trend in the power sector that will use the technologies and bring us more benefits. Already we have discussed what are the benefits from the smart grid through that structural diagram. So let us take the components. At physical level, the smart grid comprises of 5 fundamental components. So what are those? New grid components are added to our conventional distributed generation, then combined heat and power, plug-in hybrid electric vehicles, PV cells, wind turbines, etc. These are the new grid components to be added. Then sensing control devices. Under this one, sensors, IEDs, that is intelligent electronic devices, and smart meters are used. Then the third one is communication infrastructure. So communication network may be based on fiber optics, microwave, infrared, PLCC, etc. VSAT also included, that has been implemented in Karnataka. So now new communication technologies that they are using, cellular technologies that they are implementing it in the smart grid. Then automation and backend. So here at this level, we'll be having high-end servers, middleware, data storage units, DMS. Then the last, advanced analytics. So what is advanced analytics? We'll be collecting a lot of data from the smart meters. So that data has to be analyzed. So data analytics is required here. So for that one, advanced analytics is required here. Let us see, this is a conventional power system, power generation, transmission, distribution and consumption. So this is a conventional and this is the infrastructure. You can see electrical infrastructure combined with your intelligence infrastructure, that is your ICT, information and communication technology. When you combine this one, it will provide you the two-way communication. That means it will provide you the two-way communication. That means from the user to the whatever the grid center is there, from grid center to the user, you will be getting the two-way communication. That is, the flow of power is also in two-way. So this can be achieved through your ICT. Analogy. So let us compare it for better understanding. This is our physical network, existing grid. So I am combining this with the communication, then information technology. Hope you understood this one. That is smart grid. My physical system combined with communication and IT. IT plus communication. I'll call it as ICT, information and communication technology. That is your smart grid. So I am comparing that one with our human analogy. So this physical network, physic of a human being is nothing but muscles, right? So like that I am comparing it. Communication. Can anyone tell analogy in our human body? Communication. Communication. So nervous system. Then brain. So information technology is compared with our brain. What they carry. So generation, megawatt. So then communication, megahertz. Information technology in megabytes. So this is what they carry. Then what are the technologies that are used in smart grid? There are various technologies that are used in the smart grid. So let us see. Supervisory control and data acquisition system, that is SCADA. Second one, cyber security, big data analytics with machine learning. Then AMI, advanced metering infrastructure, microgrid, advanced energy storage options. Then geographic information, virtual power plants, PHVs, G2V, grid to vehicle, V2G, vehicle to grid technologies, then HVDC and fax controllers, blockchain approach in energy market, outage management, finally DSM, RES integration, weather condition information system. These are the technologies which are used in smart grid. But we are not going to focus on all these technologies. So we are focused now only on cyber security. We will be focusing it on only on cyber security. So let us see that one. What is cyber security? So first thing is, cyber security means what? It is to protect the digital devices and network system, that is communication system you will be having it, from various types of cyber attacks. That is your cyber security. Now it is digital world. Environmental impacts is not considered in the cyber security. Like we have seen, the technologies, environmental related technologies is not involved. So whenever the technologies or the services which are developed, keeping it in mind the environmental friendly things, then we call it as a green technology. Similarly here also in digital world, environmental impact is not considered in cyber security. So then what we should do? Now this is gaining an importance. green cyber security. We are seeing green technology. Now we are seeing green cyber security is gaining importance in IT infrastructure. What is this green cyber security? Now, can you tell me? I have given the meaning of a smart grid. I have given the meaning of sustainability and green technology. Now, what is green cyber security? I have given the definition of cyber security also. It is used to protect your digital devices and networks from the cyber attacks. This is the cyber security. Now, what is green cyber security? And before that statement, it is clear that in this cyber security, environmental impact is not considered. So what I should combine here? To the cyber security, I have to combine something to call it as a green cyber security. So what I should combine here? It is nothing but your sustainability. Again, sustainability. Main focus in the sustainability is for safeguarding the planet. That is green energy. So that is nothing but your green cyber security. So that is the difference between normal cyber security and green cyber security. In addition to the cyber security, if you are including the sustainability, then we call it as a green cyber security. So that means what is green cyber security? Is about securing the digital world by considering the environmental impacts. By considering the environmental impact, that means in an eco-friendly manner. Now, what are the key elements of green cyber security? Energy efficient infrastructure we should have. That is the key element of green cyber security. That means to have energy efficient infrastructure, so you should invest in energy efficient hardware and data center technologies. Then optimize the cooling system. The second key point is cloud computing. Use energy efficient data centers. And obviously renewable energy sources, we can use it. We have discussed a lot on that one. Then smart technology also we have discussed a lot on that one. That means implement smart technology to monitor and manage energy consumption efficiently. That is smart grid. We have discussed a lot on that one. And employee awareness. This is most important. Employee awareness is required in the green cyber security. So these are the key elements, 5 key elements of green cyber security. Now you can see the grid with smart and renewable solutions are more vulnerable to the cyber attacks. So it will increase the surface area for cyber attacks. How it will increase? Let us see that one. Now you can see here. First we will be having physical layer, that is our transmission distribution. Then we will have ICT, that is your cyber layer, where we will be having control, computing and communication. Combining this physical layer with cyber layer is called as your cyber physical system. That is nothing but your smart grid. So comparing this one with our system, you can see here. So this is what we are having it. So this is our physical layer or generation conventional grid, and that's the cyber layer, that is cyber part. So the entire structure, we can call it as a cyber physical system. That means conventional grid plus ICT. Combined together, we call it as a cyber physical system. So now let us see what is the use of this cyber physical system. So in the cyber physical system, ICT usage is used to improve the reliability, resiliency, efficiency of the electric grid. Then we are using the smart technologies for sensing, metering and communication, which is concerning grid operation and automation, dynamic operation of grid operation and resources, then development and incorporation of demand response, demand side resources. So these are some of the advantages, or which are the key points which are associated with the cyber physical system. Now let us see what are the cyber attacks that acts on a power system. Your power system is smart grid. Please remember that one. Now onwards, power system means it is a smart grid. sensitivity of grid is much higher to any small disturbance or event. In an existing power system, there are only two events, normal state and whenever a fault occurs, that is the another state we are having it, two states. Now grid has become digitalized. We have added ICT. Now one more state has arisen. That is nothing but your one is fault. Because of that one it is sensitive. The third event is cyber attack. The cyber attack may occur on the power system. Now let us see attack surfaces of cyber physical system. Now we know what is cyber physical system means, your conventional power system with ICT. So what are the surfaces on the cyber physical system? It may be on the sensors. So on the sensors, what type of cyber attacks that will occur? There may be a spoofing or DOS, denial of service. So you cannot access your device. So that is the attack that may occur on your sensors, or you are not in a position to use the data which you are receiving it or sensing it from the sensor. That is denial of service. Or it may be on the communication structure like MIM, that is man in the middle. MIM means man in the middle. Packet modification, eavesdropping or resource blocking. These are some of the attacks that may happen on the communication infrastructure, or it may occur on actuators. So that is authentication failure may occur, missing of deadlines will occur because of the attacks. There is another surface, data storage. So they will modify, they will attack and they will modify the data here. The last one is the computing. So under computing, the information leakage, enforced computing or timing error. These are the attacks that may occur on the computing. So these are the various surfaces that a cyber hacker can or attacker can attack on the cyber physical system. Now you can see here, Robert Mueller. So he stated there are only two types of companies, those that have been hacked and those that will be hacked. He has stated this code, but this has become old. By the time the entire world is digitized, this has become old now. So this has changed. This has changed to, so the two types of companies, those that have been hacked and those they don't know that they have been already hacked. They don't know that they have been hacked already. So this is the latest thing we will be having it. So they have been hacked and those that they don't know that they have been hacked. So these are the two things we will be having it. Just 2 minutes. डेस्कटॉप में ले गए डेस्कटॉप में ले देना. Okay, next let us see the cyber physical system architecture. So this is the architecture. The first 0th level we call it as the physical devices and safety equipments will be there. Then the second level will be having sensors and actuators. Third level PLCs, RTUs, remote terminal units. IEDs will be there. Then next level we will be having HMI, operation station, then engineer workstation. Next level we will be having data historian, production controller, control room workstation. Then we will have servers, historians, patch management, the final layer, corporate workspace. So these are the 7 layers we will be having it in the cyber physical system architecture. Now in this one, there will be a SCADA levels will be there, IT levels, information technology levels will be there, operation technology levels will be there, and ICS, industrial control system levels will be there. So let us see what are those things. Now first let us consider level 1 to level 3 is called as SCADA, supervisory control and data acquisition system. That is 1 to level 3. Then 1 to 4 we call it as industrial control system. Then we are having it the IT from level 4 to 7, that is from HMI level to corporate workspace. So we call it as IT. Then OT we are having it from 0 level to the 5th level. That is your operational technologies. So these are the different levels and different technologies we will be considering it in cyber physical system. So then priority, 0 level, 1, 2, 3 is there. So what is the priority? At lower level, the priority will be given to safety. As move on from 0 level to 7th level, the priority will be given to security. Security means your cyber security. Why? As move up to the higher level, the ICT is going to add up. ICT is going to add up at the higher levels. So therefore, the security is important there. So that is the priority given. So with this structure, ICS and OT are air gap. Air gap means what? They are not exposed to the external networks. So that is the air gapping will be there between ICS and OTs. Now what is IT and ICS? That is information technology, industrial control system. So let us see. This is IT and is nothing but your enterprise network. IT is also called as enterprise network. So in this enterprise IT network, what is the priority? There are 3 things will be there: confidentiality, integrity, and availability. These 3 things will be there. And what is the first priority is in IT, that is enterprise network, confidentiality is the priority, first priority. Second priority is integrity. Then the third priority is the availability. Like banking and financing, if you consider the enterprise network, confidentiality, the data of the users and the account details are confidentially maintained. So that is the top priority given in IT. But when it comes to industrial control system, the priority will change here. So under industrial IT, the priority starts with availability, integrity, then confidentiality. Here it is CIA, there it is AIC. So that is the priority in industrial control system. First it should be availability. So that means the power should available, then only they can supply. Then only they can check, whenever the power is available, then only they can check whether it is a quality power or not, etc. So availability, integrity, confidentiality. This is a priority given. So therefore, what is availability? All the 3 things are related to your data only. So the common point is the safety. In both the things, the common point is safety. What is availability? This availability ensures the data accessibility is available whenever it is needed. That is availability. Then integrity means it guarantees the data accuracy. That is the integrity. Confidentiality, it ensures the data privacy. So that is the confidentiality. So this is the difference between your IT and industrial control system. What is the purpose of IT? There are 4R model is there. What is 4R model? So we have to provide the right information to the right people at right time in right format. That is the 4R model. So what is right information means? Information has to be complete and accurate. That is the right information. What is right people? Only the people who are authorized should receive this one information. Means that information is available to the people who are authorized to receive it. Right time. That means right time means what? Whenever the authorized person asks for it, demands for it, then only they have to supply. That is the right time to supply. Simply they cannot supply until unless they ask. That is the right time. Then right format. They have to provide the information in a right format so that they can calculate the parameters required and they can take appropriate action. So that is in the right format. If you are giving it in zigzag way, it will become difficult for the analysis and it will become difficult to take action. So that's why always it has to be in the right form so that the operator can take appropriate action. So that is the 4R model. Because of this one, IT is important in your cyber physical system. Now let us see cyber attack on power system. So let us see. So all these things already over. Okay. Classification of cyber attacks. So how it is classified? So it is classified as component wise, protocol wise, topology wise. Component wise, so it will be at RTU level. Field components are attacked through remote access. That is, remote access means that happens in remote terminal units which are placed at remote location. What is the consequence? The control system operator supplied with misled data because of this attack. So field equipment gets damaged with bad data. So what is the consequence? Loss of service. Because he did not receive proper data as he dependent on the devices. Then protocol wise. What is this protocol? The intruder can reverse engineer the data acquisition protocols and exploit them. So because of this one, what happens? Excess generation output leads to financial loss. This we will see it in detail later slides. How he will exploit, how the generation will exceed, etc. and all those things. Safety is compromised. That is, if a line is energized, when a lineman are at work, first what he will do, attacker, he will enter to the industrial control system and he will open the circuit breaker. Supply is cut off. Now what happens? Because lineman will think that supply is cut off, so he will be doing his work. Suddenly the attacker, what he will do? He will close the circuit breaker because it has been hacked. So therefore, lineman are at work are risked. So that is through the protocol wise. Then comes topology wise. So network topology vulnerability is exploited. That means what are the attacks that happens on topologies? There are different topologies will be there. Star topology, grid topology, so many topology networks are there. So in this one, they will attack type is DOS, denial of service. So because of this one, what happens? What is the consequence? Real-time data exchange gets delayed. Because what happens? Denial of service. Service is not available for the user. So therefore, real-time data exchange gets delayed. Control center operator may take incorrect decision because data is not available. Data gets delayed. The control system operator has to take the immediate decision because something has happened there. So he will take incorrect decision. So these are the cyber attacks classification that happens. Then what is the attacker's perspective? Direct protocol attacks are not the most likely chosen attack vector. They will not choose the direct protocols. However, they will target HMIs. That is human machine interface controllers. They are going to target. That is the prime target of the attackers. So what they will do? By attacking HMI, they will suppress the alarm. That is the easiest way and less time consuming attack. Then they will have data manipulation attack. It will consume moderate time. Then process manipulation attacks. So if you want to do this on process manipulation, it will take long time. The attackers will not attack the system overnight. They will do proper survey and they will find out the weak points, then they will exploit. So process manipulation, it will take time. Now let us see what are the vectors, attack vectors on a power grid. What is vector? Attack vector means it is a path. Attack vector means it is a path through which the attacker gets an unauthorized access to the computer or network, and he will deliver payload. Payload means what? It is a malware only. Already it is sitting in the system or the network. So whenever it is required, he will trigger that one. Malware, then only it will attack. So that is the payload or malicious outcome. That is the attack vector. What are the common attack vectors? These are the common attack vectors that will occur on power grid. Malware, viruses, email attachments, web pages, pop-ups, instant messages, text messages, and social engineering. So these are the common attack vectors that are happening. Attack vectors means it will be on the network. Hack point means attack point, hack point. These are two different things. Attack vector means it will be happening in the network. Hack point means it is with respect to digitalized devices. That is a digital device which is attributed in your cyber layer. That is industrial control system. All the digital devices, sensors, HMIs, etc. will be there. So that they will be hacked. Attack vector means it is in the network. Hack point means it is in the cyber layer with respect to digital instruments. Now let us see the different attack points. Attack surface. This will increase the risk to operations or control system operator. First let us see on the attack surface. Control systems are not designed with security in mind, keeping security in mind. Because of this one, attack surface is possible. Why control system is not designed with keeping security in mind? Because the control system in the conventional power system are designed almost 30-40 years back. So when they have designed, they didn't have this concept of cyber attack. So that's why they have designed, however, they are updating it now. So this is the one reason the attack surface will be having it. So what are the control systems will be having it? Maybe SCADA, PLCC, and DCS. Or even control system of automation and manufacturing are never designed keeping security in mind. So what are the example? DNP3, Distributed Network Protocol 3. So what is this one? It is a communication protocol between the components in a process automation. That is a DNP3. Modbus. So again, it is a response triggered protocol. Response triggered protocol. It is executed using master-slave workstation. That means your PLCs. You have heard of PLCs, right? So in the PLCs, that may occur. Then the second surface will be increasing usage of COTS hardware and software. COTS means commercial off the shelf. Commercial off the shelf hardware and software. It is available on the online and it is available at lower rate. So therefore, almost all the industries and public sector organizations, they are using this COTS application. Then people are deploying COTS on their power grid because it is available at lower rate. They are deploying this one on power grid without not bothering about the security. Not bothering about the security. Security means here it is cyber attack. Then the third point attack surface will be Okay, the third attack point surface is increase in interconnection and integration. So interconnection and integration means our renewable energy sources and plug-in hybrid electric vehicles are integrated with the grid. So this is day by day it is getting increased. So then the fourth surface is new two-way systems. What is this one, new two-way systems? So here we will be using it, the smart meters. So two-way system that we will be using it, smart meters. So these smart meters will provide the facility of net metering. So it will provide the two-way communication. So the next cyber attacks on power grid may possible or will increase any digital device which is not designed properly or not having proper security aspect which is embedded on it. Then the next attack surface will be new customer touch points into utilities. What are these new customer touch points? Your mobile phones. The employees who are working in an industrial control system, they will be carrying the mobile phones. So these are the new customer touch points in the utilities where this will give a chance for attacker. Then increase number of systems and size of the code base. That means day by day the power demand is increasing. So therefore the system size is also increasing. Obviously the code size is also getting increased. This is another surface which will be attacked. Then what is the intensity of this threat? So first, generation, transmission, distribution has experienced cyber attacks. On generation, hydronuclear, it has faced. The cyber attack that has attacked the generation is Stuxnet, and the second one is Digitalized. Then the transmission system, wide area monitoring system, or it may occur on substation automation. So that is GPS spoofing. This is a cyber attack that may occur on transmission side. Distribution side, so the attack may be called as crash override or black energy 3. Already these attacks has occurred on different generation, transmission and distribution side in a power system. So let us see on generation side, let us take Stuxnet. First, two attacks, Stuxnet and Industrial, has attacked the generation system. So this is a multi-part war. How it has traveled? Through the USB ports, and it has spread into the other computers through the operating system. So this virus, what it has done? It has searched each infected PC for signs of Siemens Step 7 software. What is this Siemens Step 7 software? Which is used to configure and program the PLCs. Okay. So this virus searched each PC for signs of Siemens Step 7 software. 7 means it is a generation, 7 generation. So what is this Siemens Step software? Which is used to communicate, configure and program the PLCs, and which is available freely. So they are searched this software. So where industrial computers serving as PLCs used for automating and monitoring electromechanical equipments. Then Stuxnet reportedly ruined almost 1/5 of Iran's nuclear centrifuge. So let us see, targeting industrial control system. So almost the worm infected around 200,000 computers and caused 1,000 machines to physically degrade. This is the intensity of the Stuxnet which has attacked on the Iran's nuclear power plant. Next, Industrial. This is also on the generation side. So this malware is designed to disrupt the working process in the industrial control system, specifically those used in electrical substation. So this is the first ever known malware that has attacked Ukraine's power grid in 2016, December 17. The attack almost, what is the intensity? It has cut almost 1/5 of Kyiv, the capital of Ukraine, that is a power cut for 1 hour and is considered to have been a large scale test. So this incident is a second cyber attacks on the same grid, Ukraine's power grid in 2 years. The first attack occurred in December 2015. It is the fourth malware publicly revealed to target industrial control system after Stuxnet, Avex, Black Energy. Then this is the fourth one, Industry. So what it will do actually, Industry, it will make the protective relaying systems will be there in the power system. It will not respond. That means it will make irresponsive. So that means protective relays becomes irresponsive. Then what it will do? It will wipe off all the SCADA software which is available in the operator's workstation. So obviously it leads to plant shutdown or a partial shutdown. So that is the function it will do. So it will have directly effect on your protective relaying system. It will not operate. So therefore your circuit breakers will not be open nor closed operator unless he will give access. So malware targeting ICs. Now you can see here, this is a malware operator sitting there through the internet. He is trying to target the industrial control system where your SCADA, workstation, etc. everything is there. That is from there only it is supplying the power. Now here he has targeted with the industry. So the malware operator has successfully injected the malware into the industrial control system. So what it has done in the workstation, first the protective relaying system has become irresponsive. Then he has wiped out all the software that is available in the SCADA in that workstation, and it will open the circuit breaker, thereby cutting the power supply. There is no power supply here. This is what he has done, the malware. Then transmission line, that is wide area monitoring system. Cyber attackers survey the system before attacking. That's what I said. Overnight they will not attack. They will do proper survey and they will find out the exploiting point, then only they are going to attack. It is highly crucial to prevent these attacks for the proper functioning of your wide area monitoring system. Let us see, mainly there are 2 points, vulnerable points in WAMs, wide area monitoring system, where data can be hacked and manipulated. One is at substation, where PMUs are installed, phasor measurement units. The other one is control level. So these are the 2 vulnerable points the attacker can attack. So what is the type of that cyber attack that has happened in the transmission system? That is GPS spoofing. So what he will do, because the power system, it depends on your PMUs. All PMUs are time synchronized. So how they are time synchronized? To have a time 0 reference. How they will get time synchronized with time reference 0 using your global positioning system. They are using a GPS system to get 0 time reference. So therefore PMS are the target. GPS spoofing is very easy with COTS software, that is commercial of the shelf. That's what I said. It is available free at lower cost. Everyone they are using it because this COTS software is having a backdoors or trap doors. From there, it can pass on the information to the malicious intentions. You can download it from the internet. Then PMS are vulnerable to GPS spoofing attacks. Now let us see this picture. This is a substation you are having it. SCADA center will be there. You are having, example I have shown only 2 PMS. There are several PMS will be located at different locations in the substation. And PMU normal substation and PMU, 2 PMUs are there. And these are time synchronized. These 2 are time synchronized with your GPS satellite. So what happens? The hacker will place a transmitter there near to the substation and he will target the PMU. And what this PMU will do, instead of receiving the GPS signal, it starts receiving this transmitter signal. That means he is fooling this PMU. The attacker is fooling this PMU. So what happens? It will send the wrong signals because these 2 are time synchronized with the GPS, and also because this is getting wrong signal, this also gets wrong signal. Finally, it leads to the wrong information to the SCADA center. So this is how That's GPS spoofing attacks will occur on your transmission side. Then DOS attack, denial of service. So what exactly this DOS attack? Denial of service means a targeted server will be flooded with information traffic, or he will send enormous messages so that the system will be crashed. So that's what he will do. Then the device is not available for service. So this DOS attacks accomplish this by flooding the target with traffic or sending it information that triggers a crash. So these DOS attacks can cost an organization both time and money. So denial of service, it may occur on different networks. These are the types of network topologies that will be used. Suppose if an attacker applies denial of service, he will attack. If you take star topology here, so this is a central grid, so central port I am attacking it with a DOS attack. So when he attacks with the DOS, denial of service, easily he can attack this one and all the nodes that are connected to the central nodes. So he will connect only one node so that whatever the surrounding nodes are there, all those nodes gets hacked and it will be attacked. Then distribution side, crash override. So crash override, it is a network, a support group. So it is like an online abuse. It is composed of a backdoor and 4 payload components. Already I have explained what is payload. Malware is already existing. Only thing is it has to be triggered. It has to be acted. So they will look into the time and then they will trigger, and then they will include this malware in different networks and different computer systems. So these payloads will try to gain direct controls of switches and circuit breakers at electricity distribution substation. So first what it will do, the malware first maps and discover the targeted device. First it will do survey and it will target the devices which are having COTS software, commercial off the shelf. Then issue commands to modify these devices behavior. So this entire statement is nothing but your payload. That is known as payload. First it will search and it will target and malware will be installed. Then it will give instruction or commands so that they will modify the device behavior. So you see, first compromise the data historian and access SCADA DCS devices through which it will open the circuit breaker at victim side. So it will create a large transmission failure. Then he will execute a denial of service on protective relays. That means protective relays become irresponsive. So then what happens? It leads to anticipated physical reconnection. What happens? Now the circuit breaker is opened. Suddenly he will close the circuit breaker. So this is anticipate the physical reconnection. So what happens at this stage? Whenever this execution DOS is there, your load is disconnected on the generator. Generator will be rotating without load. So generation continuously increases. Nobody is there to consume because of this attack. So suddenly you close the circuit breaker. Again, what happens? Physical interconnection. Again, the load will be suddenly connected onto the generator. What happens? Generation is increasing earlier because of circuit breaker is open. Suddenly you will close the circuit breaker. Then again reconnection will happen. Again what happens? Again the load is connected to the system. So therefore what happens? The generator gets damaged. Then black energy is the virus that attacks the distribution system, is a Trojan that is used to conduct DDoS attack. DDoS means distributed denial of service attacks. I have given DOS. Denial of service means one computer to one computer. Only one computer will send the several signals or several messages to one computer. But here DDoS, distributed DOS means several computers are used. Multiple computers are used to attack a single machine with heavy traffic of information. So that is your distributed denial of service attack. So that is cyber espionage, information destruction attacks. So black energy 3, what is this one? 3 means it is a variant, that's all. Generation we say no 4G, 5G, etc. Like the black energy 3 is a variant of black energy. So this is used in the first Ukrainian grid attack in the 2015. How they have attacked? How they have used this black energy 3 virus here? Through your phishing emails. They have sent a phishing emails to the control system operator, because earlier the SCADA system is used to monitor and control as well as to receive and send messages, the same SCADA system earlier, 2015. So that's why they have sent a phishing mails, so that through the phishing mails they are able to access the distribution system through this black energy 3. Now let us see the attack scenarios. Okay. Now till this point, I can say through the internet, then you have a firewall here, then IT, DM, information technology, demilitarized zone. This is known as demilitarized zone. This is a additional security layer here we'll be having it. So this is not exposed to the external network. And we'll be having web server. Then here we'll be having information technology. Then we'll be having ICS test bed here. Then again through the firewall, we'll be having industrial control system demilitarized zone, then industrial control system network, then antivirus, historian, etc. we'll be having it. Then comes our physical system. Physical system is our, again through the firewall, SCADA. So that is wide area network. Through SCADA, our substation 1, 2, 3, etc. are connected. Substation 1, substation 2, substation 3. So this is the structure of entire smart grid. Just I made a scenario. You understood, lot of layers will be there. But just to make you to understand, this is the how our substation or smart grid is deployed. Now let us see the different scenarios, how each one will attack here. So there are different attacks that may occur here. From internet it will start, then IT, then ICS, then our SCADA. This is how it will move on. So let us see here. First one, ICS insider. There are only 4 or 5 attacks. I will be listing it out. There are almost top 20 or top 30 attacks are there. But here, because of time constraint, I may take up 4 or 5 attacks with this one. So first attack may be your ICS insider. He is called as ICS insider. He is a technician who is working in ICS network, and he will be having the knowledge about your substation and the control system. He will be having the knowledgeable person. So what he will do, he will steal the passwords from the ICS network. How he will steal? Through shoulder surfing. Shoulder surfing means what? Suppose I am doing some password, he will be standing here. Through the shoulder, he may be observing my fingers or the keyboards, and he will steal the password, or somehow he will steal. He is a disgruntled ICS insider. So he will steal the password, and what he will do, because he has opened up into the control system, he is a knowledgeable person, he knows how to operate the industrial control system. So he will be having a control of circuit breakers, protective relays, etc. so that he can make anything here. Maybe substation 1 he will make shutdown, or substation 2 he will make shutdown through the SCADA network, etc. Partial shutdown or complete shutdown he will do. And this cannot be defeated. ICS incident, how you know who is the culprit? And so that's what I have given it in the previous slide. Employees awareness is very much important in the industrial control system. So this cannot be defeated through anything, because even though if I appear good for some years, maybe 5 years, since 5 years or 10 years I am working, because of some pressure, on 11th year I may steal the password for my benefit. We cannot predict. So this attack cannot be defeated. This is ICS insider. Second attack may be IT insider. He will not have any knowledge about the industrial control system. He will not have knowledge about industrial control system. Once again, he is a not satisfied man. So what he will do, again he will steal the passwords in the IT network, again through shoulder surfing. Through the shoulder surfing, he will steal the password. Through these passwords, what he will do, he will steal the passwords of ICS networks remotely. So remotely he will steal the password, but because he don't have knowledge about industrial control system, he don't know how to operate the control system. So this is an unsophisticated attack, I can say. The first one, ICS Insider, was a sophisticated attack because he had a knowledge about operations of all the control system. But this fellow don't have knowledge about the control system. So only thing is he will go inside and he will do something. He will search whether I can do something here or not. So this can be defeated. This attack can be avoided or defeated here. This is our second attack. Then the third attack. So what the hacker will do? So first he will break into the web server through the zero. He will detect the zero vulnerabilities. Zero vulnerabilities means some software is installed in this web server. So maybe it would have expired or some loopholes will be there in the software. So he will identify that one, or if it is outdated, the vendor, whoever has installed the software, before he identifies the software has expired, now I had to give a patch for updation. So that is not, that means what? The vendor will have 0 days to update the software which is available in web server. That is known as 0-day vulnerabilities. So what he will do, he will have broke into the web server and he will find out the 0 days vulnerability. Then he will broke into IT, information technology demilitarized zone. And what he will do, he will use the RAT, remote access tool. He will use that one. Then he will steal the password. Through that one, he will find a way into the IT network. So he will broke into IT DMZ, he will steal the password. Then through the passwords, he will find a way into IT network. Then through the IT network, again he will use the RAT tool. Again he will find a way into the control system. He will enter to the control system and once and keeps the malware. So when he keeps the malware, obviously this fellow will have a control of this control system. So again here it will be denial of service will be there. So this is a third attack, I can say scenario. Then the next one, the hacker. So what he will be doing it through the internet, he will gain access to the IT network, information technology. Again here he will do the zero vulnerability and he will exploit that one zero vulnerability point and he will enter into the IT. Again he will use the RAT tool, remote access tool. He will steal the password remotely which are available accessed in the industrial control system. Again he will gain access into the first he will go to demilitarized zone, then he will attack the control system here. First from here he will go. So how he can able to go to demilitarized zone? This is the antivirus. So by the he knows when this antivirus is going to expire. So but the vendor he don't know sometimes when it is going to expire. Even though he identifies yes it is going to expire, he will not have a time to update or provide the patch. So by that time, this attacker who is sitting here, so he will directly enter into the ICS DMZ. Then from there, he will gain access to your ICS network. So once they gain access into ICS network, easily they can't do anything with our SCADA system or substations. Very dangerous thing. So we should see that they should not enter into the ICS network. Then the last attack, the fifth one, your phones, mobile phones. So what happens? The employees who are working in the ICS or in the SCADA system, so they may be carrying the mobile phones and they know who are the employees they are working and they will create attractive apps. They will create attractive apps and they will supply the apps to them, or somewhere through the social network, they will find that something attractive app is available there. So they will download. Okay, that software will be running in the background. So as soon as that employees enter into the area, maybe it is ICS DMZ zone or ICS network zone or SCADA zone, whatever it is, because already some app has been downloaded in the mobile, it is running background. So it will, as soon as it enters into the area, it will do the survey of all the Wi-Fi networks available in that area. Through that area, the person who is sitting here, he will try to see the password through the mobile phone. You will access the Wi-Fi network. Through that one, you will access, then you will enter into ICS DMZ, then into ICS network. Mainly we should see that the person, that fellow should not enter into ICS network to safeguard our power system here. So this is the another third attack which is going to, sorry, this is the fifth attack. I will taken it example like that. There are 20 top 10 attacks are there, 10 top 10 attacks are there. So I have taken only 5 attacks to explain how they are going to attack and whether it is can be defeated or not defeated. Now you can see strictly we have to instruct the employees, whoever is coming to ICS DMZ zone, IT DMZ zone, not to download any apps, or nowadays they are providing their own mobile phones when they enter into the network area. However, somewhere they may be using it, so they will be waiting for the weak points. Whenever weak point is available, they will stop. So that's the thing, we'll be using it. So then cyber attacks, several cyber attacks happened on the power system. You can see 2010 on nuclear Iran plant, 13 hydro generation New York, 14 Korea hydro, then 15 it has happened in Ukraine, almost 2.3 lakhs people got affected. Then again 2016 it has happened on the same power grid, Ukraine power grid. So again it has happened, 28 lakhs people it has affected. This is the cyber. Then attacks in India. So first one in 2017. So malware attack on THDC Limited, Tehri Dam in Uttarakhand. Then the second one in 2017, a ransomware attack on West Bengal State Electricity Board. Third one 18, Rajasthan, it has happened. That is on distribution company. In 18, again distribution company in Haryana. Then fifth one, nuclear power plant. However, this has been not disclosed. Kudanakulam nuclear power plant, they attack. Then the sixth one, April 19, it is in Andhra Pradesh, Telangana state power utilities, it has been attacked. This also they have not disclosed. They told that one there is some technical problem is there. Nowadays they will not disclose, it is a cyber attack. Then current security silos. So what they will do, nobody has got any clear picture about cyber security. When a person looking at tail end, he will say it is a rope. When he is looking at this point, it say it is a wall. The other person, if he is holding a leg, then he will say it is a tree. Then if he is holding some grass or something, he will say it is a snake. He will looking at this one, he will say spear. Then when he is riding on an elephant, he will say it is a fan. So different, no one has the complete picture about the current scenario of cyber security. Depending on the person's availability, they will say this is a cyber attack, this is a cyber security, etc. So what are the best practices? So these are the best practices, we will be having it. We have to follow, I will be running through. So mainly there are 3 disaster drills we have to do it. So this one, disaster response drills, regularly they have to conduct, and intrusion detection system IDS they have to install. However, this software may or may not stop the attackers. Then you have to use VAPT, vulnerability assessment and penetration test. Frequently you have to do it. Then decoy. So what is decoy? One original PMU will be there, instrument. Then you have to create 100 virtual PMUs, so that the attacker don't know that which one is original. So this is the one type you can do it to avoid the cyber attacks on our system. So what is the loss of cyber security? Nothing is secure. all softwares can be hacked. So all cyber attacks are nothing but your information. Every bit of information can be an attack. So these are the three laws of cyber security will be there. Even whatever the patch, whatever the precaution we take, they will come out with another solutions, the attackers. So this is what already is told. There are two types of companies that have been hacked, and those that will going to be hacked. But it is outdated. Now present one is already have been attacked, and somebody they don't know that they have been already attacked. So this is the new company we are having it. So these are some of the references I have taken it. And these are the standards which you can follow it for any cyber security. These are the standards we will be following it. National Institute of Standards and Technology, you have to follow. Thank you, Ananda. Any questions?
This dynamic power distribution, is it already adopted in the India?
Yeah, it is adopted. Already it is going on. Pilot projects are going there. Smart grid pilot projects are there. Near Mysore one is there in Karnataka state. Any questions? Simple questions you can ask. No questions. Because this is after lunch session, whether you understood or not, you understood completely or you are not understood anything. Maybe you would have gone above your head, whatever it is. Any questions, please? Once again. No questions, please. It's okay. Thank you. Thank you, Ananda.